Okay, let's start the section 5152 video review lesson or video lesson for tonight. This should be primarily a review. It's all about integral exponents and scientific notation and some of the power rules. We're going to do it all, those two sections all at once. And then tomorrow in class we'll do the bookwork. So remember, a positive integral exponent, if a is a non-zero real number, and n is a positive integer, then a to the n is equal to a times a times a times a n times. In exponential form, a to the n, a is the base and n is the exponent. In negative integral exponents, if a is a non-zero real number and n is a positive integer, then a to the negative n is 1 over a to the n. And what that might look like is, if you think about 5 squared, that's equal to 25. If I divide both sides by 5, that gives me 5 to the first is equal to 5. Again, if I divide both sides by 5, this time I get 5 to the 0 power, which is 1. Now, if I divide again by 5, I get 5 to the negative 1, which is equal to 1/5. And you'll see a little more of those negative exponents. That's probably something that is relatively new. So if we look at finding those negative exponents, or those values, for a, 2 to the negative 3 becomes 1/8. B, 5 to the negative 4 becomes 1 over 625. C, 3 to the negative 5 becomes 1 over 243. And D, 2 to the negative 5 becomes 1 over 32. Rules for negative exponents. The following rules hold if a and b are non-zero real numbers and n is a positive integer. So when we look at that idea of a over b to the negative n, what that might look like if we actually did all the algebra is I have a to the negative n over b to the negative n, which becomes 1 over a, 1 over b. That gives me that complex fraction, which I don't want. So I'm going to multiply by the reciprocal, which gives me b over a. And so that's how I get b over a to the positive n. So you can just flip that a and b, take away the negative symbol. Again, if I have a to the negative n, that becomes 1 over a to the n, which is 1 over a to the n. If I have a to the negative 1, that's just 1 over a. If I have 1 over a to the negative n, that becomes a over n. So what that looks like is I have 1 over a to the minus n, which becomes 1 over a to the n. Again, multiplying by that reciprocal, top and bottom, I'm going to end up with just a to the n. Okay, the zero exponent, if any non-zero real number, a is a non-zero real number, a to the 0 equals 1. So anything raised to the 0 power is 1. You could have 100,000 raised to the 0, that's 1. And we saw that in that example in the beginning. The product rule for exponents says if m and n are integers, and a is not equal to 0, then a to the m times a to the n is equal to a to the m plus n. So if we look at this example, I have b to the 5th, so that's b times b times b times b times b. Then that's multiplied by b to the 3rd, which is 3b's, which gives me b to the 8. So I can look at this as b to the 5 plus 3 equals b to the 8. So if bases are alike, I add those exponents. The quotient rule of exponents, if m and n are integers, a is not equal to 0, then a to the m over a to the n becomes a to the m minus n. So in this case, we have 2 to the 9th divided by 2 to the 4th. If you put all those out, you could just cancel all those 2's. But what it looks like is 2 to the 9th minus 4 becomes 2 to the 5th. Power of a power rule, if m and n are any integer and a is not equal to 0, then a to the m raised to the n is equal to a to the m times n. So I'm multiplying those exponents now because that looks like 3 squared times 3 squared times 3 squared times 3 squared. So that's going to give me 3 to the 8. So I'll multiply that in the power rule. In the power of a quotient rule, if a and b are non-zero numbers and n is an integer, then a over b to the n is the same as a to the n over b to the n. So in our example, that becomes 2 squared over 3 squared. Variable exponents, so that's when I have a variable in my exponent, not just a number. All the same rules still apply. So if I'm taking 3 to the 4y times 3 to the 5y, bases are alike, I can add those exponents. I get 3 to the 4y plus 5y, which gives me 3 to the 9y. Number 2, power rule. I'm going to multiply those exponents. So I have 5 to the 2x times 3x, which is going to give me 5 to the 6x squared. And in number 3, I have 2 to the n over 3 to the m, all raised to the 5n, which is going to give me 2 to the n raised to the 5n over 3 to the m raised to the 5n. And I'll just multiply those powers. That will give me 2 to the 5n squared over 3 to the 5mn. In an application of exponents, we have the amount of an investment P, where P is dollars, with an interest rate R, compounded annually for n years, is given by this formula. A is equal to P times 1 plus R raised to the n. So the problem says finding the amount. According to Fidelity Investment of Boston, U.S. common stocks have returned an average of 1% annually since 1926. If your grandfather had invested $100, so that's P, in the stock market in 1926 and obtained the average increase each year, that's going to be the annual rate R, then how much would the investment be worth in the year 2006 after 80 years? And that would be our time, N. So the amount we would have would be equal to the principal, 100 times 1 plus the rate, which was 10%, raised to the 80. Don't forget order of operations here. Order of operations says I'm going to have 100 times 1.1 raised to the 80, and that would give me $204,840.02. Okay, next, scientific notation. Remember, scientific notation just provides a convenient way of writing very large or very small numbers. And we can actually apply the rules for exponents to scientific notation, which we're going to take a look at in just a minute. So for A and B, all I'm going to do is rewrite those in standard form. So for the first two, I'm going to rewrite that. So I'm going to move that decimal 5 places to the right. If the exponent is positive, I'm going to move to the right. So that would be 762,000. Now in B, that is a negative exponent, so I'm going to move the decimal 4 places to the left. That's going to give me 0.000635. Now C and D, I'm going to write as scientific notation. So now my decimal place is at the end. I'm going to move that all the way over so I have one significant digit, which would be 9.34 times 10. Then I have to count how many places I actually moved that. So 1, 2, 3, 4, 5, 6, 7, 8. 10 to the 8. Now for D, I have 0.000025. I want to move that to the right, so I have one significant digit. So that would be 2.5 times 10. Then I have to count how many places I'm moving that decimal. I'm going to move it 6, so that gives me a -6. Okay, let's take a look at using scientific notation to make some computations. Here I have 2 times 10 to the 7th times 6.3 to the 10 to the -11. I can rewrite that as 2 times 6.3 times 10 to the 7 times 10 to the -11. So here I have bases that are alike, so I can use the rules for exponents. So I'm going to go ahead and multiply the 2 and the 6.3 gives me 12.6, applying the rules of exponents, times 10 to the -4. Remember, if bases are alike, I'm adding those exponents. Now I want to rewrite that with one significant digit, so I'm going to move that 1 unit to the right. I get 1.26 times 10 to the -3. In number 2, I have that as 7/2 times 10 to the 13 over 10 to the 6. 7 over 2 is going to give me 3.5 times 10 to the 7th as that answer. The next one, number 3, I'm going to rewrite as scientific notation and then apply the rules for exponents. So this becomes 1 times 10 to the 4th times 2.5 times 10 to the -5 over 5 times 10 to the -6. So you have both the product rule and the quotient rule happening. Go ahead and apply the product rule first. So you're going to have 2.5 times 10 to the -1 over 5 times 10 to the -6. You can then take 2.5 divided by 5. That's going to give you 0.5 times 10. Now the quotient rule, you have -1 minus -6, which becomes a positive, making that 10 to the 5th. You want to move that so you have one significant digit. So it's going to be 5 times 10 to the 4th. Okay? So now let's take a look at a few problems. If you want to separate these, you can say you have -3 over -21 times a to the negative 3 over a to the negative 4. So 3 divided by 21, that's going to give me 1/7 times a to the minus 3 minus negative 4, which is going to give me a over 7, because this becomes a to the negative 3 plus 4. Looking at number 2, I have 10 divided by negative 2 times x to the negative 6 minus 2. So 10 divided by negative 2 will give me a minus 5. X to the negative 8. We don't want to leave our answer with a negative exponent, so I'm going to rewrite that as minus 5 over x to the 8. Number 3, I have 2 over 10 times r to the minus 3 minus 5 t to the minus 1 minus negative 3. So that's going to give me 1/5 r to the negative 8 t to the first. I don't want negative exponents again, so I'm going to rewrite that as t over 5r to the 8th. Number 4, I have 6 over negative 2 times a times negative a, so I'm going to bring that negative out front. That's going to give me a squared b to the minus 2 over a squared b to the minus 3. I can cancel the a's, so I'm going to have negative 6 divided by negative 2 is 3, and then that's going to be times b to the minus 2 minus negative 3, which is going to give me 3b. There's a minus in there. Okay, and that's the answer for that one. We'll do 5 and 6, and then that will be enough for the notes. You should go ahead and finish 7 through 14. We'll go over those answers tomorrow, but let's finish 5 and 6 now. So now I'm going to take the real numbers. That's going to give me a minus 2 times a minus 3 over a minus 6 times I have x to the minus 5 times x to the first, y to the first times y to the sixth, and then in the denominator I'm going to have x to the minus 6 y squared. So I'll use the product rule first. So I'm going to get 6 over negative 6, which is going to give me a minus 1 times x to the negative 4 y to the 7th over x to the negative 6 y squared. So I'm going to have minus x to the negative 4 minus negative 6 times y to the 7 minus 2, which is minus x squared y to the 5th for that one. Okay, then number 6, I'm going to have 2 to the negative 3, x to the 3rd, y to the negative 6. So all I have to do is move those to the denominator, because that 2 to the negative 3 becomes 1/8 times x to the 3rd times 1 over y to the 6th. That will give me x to the 3rd over 8y to the 6th. Okay, go ahead and finish problems 7 through 14. We'll go over those answers tomorrow in class, and we'll work on the attached homework pages from the book. So if you want, you can bring your books tomorrow. Otherwise, you can share the books that are in the closet. Have a nice evening. I'll see you tomorrow.